Hello, friends. Welcome to this session on DevOps. So, as part of this session, I'm going to deal with the brief idea about what DevOps is. Now, if you're in a IT industry, then you might have certainly heard one of the most trending buzzword called DevOps. Okay, so many have a misinterpretation about this term DevOps. They think that DevOps might be one tool or one technology. Okay, so I would be in this session uh, discussing you with you people about what actually DevOps means. Right. Firstly, the term DevOps is a combination of two words, namely development and operations. Okay, and as I told you, DevOps is not a tool. Okay, so then what DevOps is? So DevOps is a practice. Okay, it's a practice that allows a single team to manage the entire application development lifecycle. Okay, we know that whenever we develop any application, it undergoes a kind of life cycle called software development life cycle. Okay, so DevOps is also a application or software development life cycle. Fine, it's a practice. Fine, the that thing has to be clear, friends. It's not a tool, right? It's a way that you develop an application software, okay, which involves the development, testing, deployment, and monitoring. Fine. The traditional approach of a software development lifecycle included design, the requirement analysis, the design, the implementation, then we had testing, then we had validation phases. Right. So over here, DevOps is a systematic approach of application development, okay, which allows us to build superior, reliable, quality software in a very quick manner. Okay, the ultimate goal to DevOps is to decrease the duration of systems development lifecycle. Okay, why I'm telling this is now if you know the traditional approach of software development lifecycle, wherein we have various phases, right? So the time duration between the design to implementation, then from implementation to testing, okay, it's too much, right? So when the developer guy has developed some application, when it goes to testing, it takes a lot of time, okay, in order to finalize the final product. Okay, that is again due to communication gap that is happening between the developer and the tester. Okay, we'll see those things now. Right, now the stages of DevOps are continuous development, continuous integration, continuous testing, continuous deployment, and continuous monitoring. Fine, so this is the approach wherein like there is uh, uh, the people over here, they're looking to minimize the time taken. Okay, so here it's not like after the system has been integrated and given for testing, it's not like the integration people will sit idle. They'll just wait for the testing people to reply. Okay, and this testing people after replying again, they are not sitting idle. Okay, they are again busy testing the further modules. Fine, so over here the approach is continuous in nature. Okay, so every now and then you always get a newer version of the application that has been developed, okay, or that has been put into development. Fine, and also with all these phases, we expect that the application development cycle is going to take a very less time, because that's the need nowadays. Okay, nowadays nobody wants to compromise with respect to time. Okay, that's the need, that's the reason DevOps has come into picture. Okay, only the approach has changed. Okay, the software development approach is changed from the traditional software development cycle. Fine, that thing you need to understand. Now moving further, we are going to deal with various tools that are part of various phases of this DevOps. Now, when I say continuous development, what are the tools involved? When I say continuous integration, what are the tools involved? Okay, that is what we will be discussing now. Fine. So let us get into one very popular tool, okay, which is part of continuous development. That is nothing but Docker. So I would be explaining you what Docker is in brief now. Fine. Now we'll just consider a scenario wherein we have a developer. Fine. So developer develops an application in Java. So he will be needing an operating system, Java interpreter, and some libraries. Fine. So they might be Java libraries or third party application library or system libraries. Fine. So in order to develop this application, the developer needs all these three. Fine. Now after the developer has developed the application, he gives the application to the tester for testing phase. Okay. So the tester now will have certain issues. Okay. Now this is the relationship between the tester and the developer. Okay, you need to, like this in a traditional approach, this is what happens. Fine. The tester says why these bugs are not yet solved. Fine. The developer says I'm working on it and will solve it as soon as possible. Okay, this all things are happening due to communication gap and due to non-continuous approach of application development. Okay, so in so the need for Docker. Okay, now over here, what is happening is the tester is finding what is certain issues, version issues, dependency issues. Now, maybe the developer, whatever he has developed, okay, the version of Java that is been used is different, and the tester who is testing might be using some different version of Java. On the same lines, the developer might be using some different version of libraries, and the tester is having some different version of libraries. Fine. So these are version issues. Okay, if there is no sync between the developer and the tester with respect to the versions and certain dependencies also, okay, then obviously the tester there will be like a difference in opinion between the developer and the tester. Fine. So over here the issue like it continues. Okay. So the tester says the code is not running. Seems like a faulty code. This is the comment that the tester is saying and is giving it to the developer. Now developer comments saying that the code worked fine on my system. Okay, over here the entire scenario is what is the developer, whatever the environment in which he is working, the developer, okay, is totally different from the tester. Fine. So in order for an application to work fine at both the places of like near the developer as well as tester, then they both should have same kind of environment. Okay, so that's the issue now. Okay, maybe the developer has developed the application on Linux flavor and the tester is testing on Windows, right? That might happen. Fine. And also the libraries what the developer was using, maybe those libraries are not available near the tester, right? Due to which the system, okay, the tester says that the system is incomplete or it has got some app errors. Fine. But developer will keep on arguing saying that the code worked fine on his system. Okay, so in such a situation, what might be the solution? Okay, the solution at the max may be that the developer may do what is the he will create the entire image of the operating system along with the application and give it to the tester. Okay, this is the max that the developer can do. Okay, the entire image of the operating system which had got the interpreter, the library, the application, everything. Okay, so that the tester can have the same environment at his place and he can test the application now. Okay, but whether this is feasible, not feasible, because when you think of porting an operating system image, okay, it takes a lot of space, like in terms of GBs. Fine, some 5 to 6 GB, okay, will be needed in order to port the operating system. Fine. So that's not a feasible solution because you are not the alone developer or the alone tester. There might be so many projects that are running in an organization, and there are so many developers, and there are, and again, with respect to those developers, there are so many testers, right? So how are you going to manage the entire thing? Okay, wherein, so like high huge amount of applications in terms of GBs are been like ported from a developer to tester, again from tester to validation. Okay, it's not that feasible, fine. So what might be the solution? Okay, there was a need of some package that included the application and all the dependencies, and which can be easily ported with a plug and play feature. That is what was expected over here. Okay, no doubt there is an application which has been like which is running successfully at the developer end. The tester wants to have a package wherein all the needed dependencies or all the libraries that were needed for the application has to be bundled, okay, and given to the tester. So that is where this Docker comes into picture. Okay, so Docker is a software that allows us to wrap the application along with the needed libraries, both system libraries as well as third party libraries, and some functionalities. I'm not saying the entire operating system, and some functionalities of operating system that are needed for that application. Okay, so I'm saying what is Docker is a software that allows us to wrap the application along with the libraries, along with the functionalities of the interpreter, along with the functionalities of operating system needed. Okay, so inside an entity called a container, inside an entity called a container. Okay, so the whole approach over here boils up to the concept called containerization. Okay, so you build an application, so whatever the other softwares or the libraries are needed for that application to run successfully, they all together are wrapped inside a entity what is called as container. Okay, so in order to create a container, we have a software called Docker. Okay, so Docker is a software that allows us to create operating system level virtualization, which is called containerization. Fine. Okay, so this is what Docker is. Now when I compare this Docker architecture with our virtual machine architecture, how it differs, let's see. Okay, now over here, if you see at the application level, we have the applications. Okay, then these applications are running in VM, in virtual machine. These applications are running independently on the operating systems, like the guest operating systems. Okay, now if you want to like test this application 3, then this entire operating system along with the application 3 has to be given to the tester. Okay, the same if you want to test with application 2, then the entire operating system along with application 2 has to be given to the tester. Fine. So this is the like approach of virtual machines, wherein the hypervisor does what is it creates image of the hardware and creates the operating systems, guest operating system. Okay, so all of these guest operating systems are been working in a shared environment. Okay, the guest operating systems, they share the underlying hardware. Fine, but they'll be, and the processor whatever is available, okay, it works in a round robin fashion, and the users are put under impression that they have the dedicated hardware. Okay, so that's the like special feature of virtualization. We have only one operating system. Fine, and on top of that we have a hypervisor that creates a virtual image of this hardware and give it to all the guest operating systems. Okay, so all the guest operating systems are working in a shared environment. Okay, whereas in Docker what happens is containers are created. Okay, so we have a container engine called Docker. Okay, at this place we have the Docker which has been installed as a container engine. So it does what is you it allows you to create containers. So inside the containers, all the needed binaries of the operating system and some libraries, system libraries of the operating system, along with the application are bundled inside what is called as a container. So this becomes entire one container. This is another container, and this is another container. Okay, and one more very important thing I forgot to tell you is these containers, whatever space is been needed for these containers is hardly in terms of MBs. Okay, so when you create one container, it may be of size at the max. Minimum size is like some 30 to 50 MBs. At the max it may go in terms of MBs only, like 200 MB, not in terms of GBs. Okay, not in terms of GBs. So it becomes very easy for the developer to port these containers. Okay, now porting these containers also is we have a very different approach. Okay, it's not like one to one they are been ported. These containers whatever are been created, they are put into a centralized repository called Docker Hub. Okay, so that we'll discuss now. Now Docker installation on Ubuntu. First, we need to run this on Ubuntu. Open the terminal, need to run sudo apt get update. Okay, then next is like run sudo apt get install docker.io. Okay, so if your internet speed is good, it will hardly take 8 to 10 minutes for this Docker installation. After Docker is successfully installed, you can run the command. Okay, so to check out the version of the Docker. Okay, now we'll do what is we'll install Docker on our system, that is on Ubuntu, and we'll check the various operations that can be done on Docker. Okay, friends.